Well, good evening, you two. Welcome to another Verso video. This week you've got me making the video, and we're going to be looking at a mathematical concept known as mass. And mass is a very simple concept to understand. All it basically means is how much a certain object weighs. So however much it weighs is how much mass it has. Now, one very important thing that we need to know about mass before we get into weighing things and having some fun with that. And that is, if I have something, let's say I have this lump of Play-Doh just here. No matter what shape I make it, I could make it into a ball. I could squeeze it into its flattest shape possible, into a pancake. I could roll it out into a really, really long snake. Okay? No matter what I do to this lump of Play-Doh, it is always going to have the same mass no matter what shape it takes. And the reason for that is the fact that I haven't added anything to it and I haven't taken anything away from it either. All I've done is change the shape of it. So if I was strong enough to be able to squish this down into a really, really, really tiny ball, but still kept all the same amount of Play-Doh in there, it would have the exact same mass as if I'd stretched it out into its biggest shape possible, like a really long, flat snake. So rule number one with mass is no matter what shape something takes, if it's always got the same amount as it started with, it's always going to have the same mass. So now that we know that your mass stays the same no matter what shape something takes, as long as you haven't taken anything away or added anything to it, we come to the second part of mass, which is working out whether some objects are heavier than others, and a really good way of doing it. So the best way for us to measure this is by using something called a pan scale or a pan balance. They're both used interchangeably. Now, what this looks like is basically a long pole, a bar across the top, and then two bowls on either side. And you're going to see that in class next week or the week after. Now, unfortunately, I'm at home and I've left my pan balance at school. And so I'm just going to have to pretend to be a pan balance myself to show you how it works. All right, so just give me a moment to set up. And then we're going to see how pan balances work. So this is me being a pan balance. So as you can see, in my hands, I've got two bowls. And my arms are perfectly equal. So they're not going this way and they're not going this way, but they're perfectly straight, which means that I have an equal mass in both bowls. The reason I know that is because they're both empty. So it's very easy to tell that if they're both empty, they're both going to have the same amount of mass inside them, the same weight. But if I was to put something inside them, and this is where my lovely assistant Beth, and she's a bit embarrassed because she's in her pajamas, but my lovely assistant Beth is going to come and help me. So she's going to come in now. Yep, come in. And she's going to smile and wave at the camera, and she's going to put the lump of Play-Doh, sorry, not plastic, lump of Play-Doh we were using before, she's going to put it into our bowl. And all of a sudden, because it's now got a greater mass in this bowl than this bowl, because this is still empty and this has the Play-Doh in it, the heavier side sinks down. And what I'm going to try and do now, well, I'm going to get Beth to go and grab some pens from the fridge. So she's just going to walk across the screen because we didn't set this up properly beforehand. And she's going to see how many pens it takes to get our pan balance back equal. And so let's see how many pens is going to be needed to equal the mass of the Play-Doh. So we've got one. And as you can see, as they start going in, the pan balance start evening out. 2, 3, 4. Oh, all of a sudden, we've gone too far. And so now, as you can see, this side has a greater mass that is now heavier than this side. And so what do we need to do you think? Beth, what do you think we need to do? That's right. We need to take out a pen, and all of a sudden, we're back equal. So the mass of one lump of Play-Doh is equal to, I can't actually see, Beth, how many? 4. 4 pens in the other bowl. And so we can say that the mass of this lump of Play-Doh is equal to 4 pens. And we're going to be using actual pan balances over the next couple of weeks to find out the mass of different objects and how they're equal and how they're different. Alright, so to make sure that we know that you've watched this video and understood it, you need to answer
2 questions.
2 questions.
Question number 1.
Question number 1 is, if I get a lump of something, let's say it's Play-Doh, and I squish it, and then I stretch it, and then I roll it, and I do all these sorts of different things to it, and I end up with a really long, thin snake, have I changed the mass of the object? Question number 2. Wow, that was nice. Well done. If the mass of the object hasn't changed, why hasn't it? Why is it still the same mass, even though it's a completely different shape? So if you answer those 2 questions correctly, we know you've watched the video. And as always, I will see you in class. Beth probably won't.